Now we're going to consider sliding friction. So when two bodies are in contact, there is friction between them. When we are solving problems, we need to look to see what type of contact there is between two bodies. If we are told that there was a smooth surface implies smooth contact, then we say there's no friction involved. If, though, we're talking about rough contact or rough surfaces, this means that there is friction involved. Now, friction will always go in the opposite direction to motion. So it's in the opposite direction to motion. We have a formula to calculate friction. The formula is given to you as vector F, which represents friction. Sometimes in physics you'll see that with an F with a little r, equals the coefficient of friction, which is mu, times the normal reaction. So friction is equal to the coefficient of friction times the normal reaction. Okay? The rougher the surface is, the greater the friction. So, if we're looking at a smooth surface, there is no friction. So we say mu is 0. If we had a mu value, a coefficient of friction value of 0.1, there's a relatively low level of friction. If we said 0.7 is our coefficient of friction, obviously there's a lot more friction that is involved. There are two types of friction. For the most part, we will deal with dynamical friction. That is the study of dynamics, the name of this chapter. Dynamic friction occurs when the body is moving. If the body is still, then there is what we call static friction. Static meaning not moving. To solve a lot of the problems, what you'll need to do is draw force diagrams. On the force diagrams, we do not bold arrows or anything else. We just draw them as normal lines.